I put my entire computer screen on this tiny display smartwatch. And no, this is not a picture or a video, it is real-time stream from my desktop live. And as a bonus, we now also have audio. So in this video, I will show you how you can make this project on a dev kit board from Waveshare. So without further ado, let's just jump right into the video. Okay, so you can see my screen now, and I'm going to talk about the hardware. So I'm using this board from Waveshare. It's a very nice board. It basically has almost everything I needed. The best one is the AMOLED screen. We're using the codec. We're also using the touch driver here, and all of this is controlled by an ESP32-S3, so we got pretty powerful system. And then we also have 8 megabytes of PS RAM to store the image buffers. So now this is the hardware that I'm using with, and I mean, you can see my watch in the screen as well. There should be somewhere on the I'm probably put it somewhere here, I don't know for sure, but you'll eventually see it on the video. Yeah, on the software side, I have basically made a Git repository. So, and then I have made this readme so you can follow the instructions, but I'll also give you a general overview of the architecture. So we have two main components. There's a Python server running, and then there is the firmware on the watch itself. Now the server, essentially, this is, if it's too complicated, I'll just simplify everything. You capture the screen using like a method. It could be anything. I'm using my CPU's graphics driver to get super fast captures. Anyways, you capture the screen, you capture the audio, you merge them in, frame it in, and then you send it over to TCP. Now the ESP will read that information. It will basically get the information on the packet incoming, and then it'll decode the JPEG data into JPEG, and then it'll decode the audio, not decode, but it'll just send the audio data to the DAC and over I2S, and basically we just repeat these things over and over again, and that's what happens. And we see the video stream with the audio on, like the demo. And I mean, yeah, you can go over this document, and you can also play around with this on your own. If you have been following my channel, I'll show you what I'm talking about. So I have made, I think, 2 versions of the same project in the past, this one and that one. And yeah, a lot of people in the videos asked me how to do a tutorial, so I'm doing a tutorial as well on how to set it up, and I'm going a little bit in depth on it. So the difference between this one and that one are, I think there's 2 major categories of difference. First of all, the functionality. The new one, which I'm talking about in this video, will be much better in performance. It's much smoother. The hardware is different too. Now you have to have a separate dev board. So that one was more flexible, the original, because it's just generic open source code on Arduino IDE. This one's a bit restrictive, although with these restrictions, we were able to make something that's more better and has more functionality, in my opinion. Another thing is that I moved to Espressif IDE. So instead of Arduino, I'm using this build flow. This gives me more flexibility and better performance when in the longer run. That was another decision I had to take. So let's look at the watch now. So yeah, I'm back at the IDE now, and let me boot up the watch. So you should be able to see the watch. Now on booting up the watch, it connects to Wi-Fi, and I have it already programmed because the Wi-Fi info is stored on the non-volatile flash storage, so it doesn't have to reprompt it. It'll only prompt it either if the network wasn't found, or if you notice initially there was a button you can tap on, and it will basically reconfigure the Wi-Fi. Configuration is described in the README. There should be a section somewhere. Yeah, right here. So it should be straightforward if you have done it. Now, what we have to do is we have to run the Python server. So again, I can also show you how to reproduce this thing. You clone the repository and then open this main folder inside Espressif IDE with Espressif IDE on a cursor, and then you can basically build it. So once you build it, you'll basically flash this. Now once you have this firmware screen seeing, you should run up your Python program. Another limitation is that make sure the computer and the watch is on the same wireless network, so they should be on LAN. Now, what we see here is on the Python thing, we see here settings. So let me show you something. So basically, you can choose what resolution you want. I'm just going with the format, so don't change this. You can change this because this is the JPEG quality. I set this to 60 just to demo right now, and let's just start it up. So now the server is running, and basically it's waiting for the watch. So there are two sliders here. There's a volume slider you can use to control the volume, and then there's the find desktop. So you click on the find, it'll start looking for something, and once it's find it, you'll see on the screen, and then you also see it on the screen of the watch, and you also see it on the console. Now you just have to click the green arrow on the watch to confirm it, and now you have your stream working. So let me zoom in a little bit and make it a bit more cleaner. So I chose a smaller resolution, and I also chose 75 quality, so it's not the best quality, but you can see at the bottom the FPS is peaking at 45, 44, and yeah. So this is basically the project. This will start streaming your computer, and you can just go on and just start playing videos as well. I have some demo videos with audio, which I showed. So you can see like how the latency is, and you can tell it because I'll put both these side by side. And I think that's all for this. You can stop it, so you can click on the blue bar here on the screen of the watch to stop it, or you can also click stop on the server. I'll click here. Once it's stopped, it'll disconnect, and now if you do this first slider, it'll automatically prompt a connection, but since I have it off, I have to manually click find desktop. Now what we can do is we can stop the server, and we can try to make the screen a little bit bigger. So we can also rotate. So let's say we wanted to view it like this, so I go 270, and then I switch it to say 400, and I switch the height to say 380. These are just random numbers. I will expect the quality to drop, so let me just reduce the quality, and you'll see it started. Now I'll click on find desktop. So once I find it, I click checkbox, and now we have a bigger display. But as a trade-off, you can see that the FPS is now in the 20s, and there might be a bit more stuttering and more latency. But you can see there was also a little bit more latency on this, and I think the reason for latency is more likely the Python script, because there is issues when we try to recompress the frames. So you can play around with these values, you can play around with these settings and see which works for you. But overall, this is a pretty general flexible interface that you can use. And yeah, that's all I had for this video. I hope you enjoyed this project, and again, you can find the links to the GitHub repository and another blog post that I'll write about this in the description or the pinned comment. So again, thank you for watching this video. Hope you have a great day.